Thank you for joining today, everyone that's out there. We're going to wait a minute or two before we get started, just to give everyone time to log in here. Thank you, everyone, for joining us. Just one last reminder, we'll get started in a minute or two. Just want to give everyone another couple minutes to get logged in. One last heads up before we start. We got about 30 seconds or a minute before we get started. All right. Welcome, everyone. My name is Andrew Weaver. I'm the Global Engineered Solutions Product Manager here at Adhesives Research. We're excited today to speak with you about the PSA technologies we have and how they can enhance the development of EV batteries and other emerging battery technologies. Thank you for taking the time out of your day to join us. We hope that you find it informative. I have a few housekeeping items that I want to go over before we get started, and then we'll provide an overview of Adhesives Research and how we feel this content is relevant. I'm also joined today by Matt Hunley. Matt is our Engineered Solutions Group Leader. He will be presenting a technical review on conductive pressure sensitive adhesives and how they can be used specifically in EV batteries. We will end the webinar with the Q&A session with Matt and myself. Please feel free to submit any questions you have now or while you're listening. We will collect them and then answer them at the end of the presentation in the Q&A session. In an effort to provide the most effective delivery, we are and will be in a listen and view only mode. As previously mentioned, though, there will be a Q&A session at the end where we will be able to answer any of your questions that come up throughout. If you prefer to send those questions anonymously, you should have the option to do that, if that makes more sense. If we are not able to answer your questions during the live event, we will make sure to follow up afterwards, and we will likely follow up afterwards anyways, even if you don't submit a question. This presentation is being recorded, so you can access it later, and we'll get a link out to you as soon as that's prepared. And last but not least, please raise your hand if you have any questions or need assistance in other ways. We do have a few members of the Adhesives Research team online today, and they'd be happy to reach out to you while we're presenting. The purpose of this webinar is to discuss how high-performance pressure-sensitive adhesives, or PSAs, can enhance the development of emerging battery technologies. It's no secret that the electric vehicle market is in a unique position for sustained substantial growth. Whether you're a new startup here today with us with high ambitions or a seasoned veterans at the forefront of the industry, staying ahead of this curve is paramount. We at Adhesives Research feel that there are several market drivers that serve as strong indicators towards this growth. First, growing public concern over global warming. It's driving demand for policy and investment in green technologies. This is steering multinational agreements like the Paris Climate Accord that you've all heard about in the news, down to local policies and regulations, setting more aggressive emission standards. This shift in public demand is what is driving this market today. Another market driver is the advance of electronics and computational efficiency. Most people don't think about this as a driver for the automotive or EV market, But as with any technology, it goes through a life cycle maturity. We are at a time when other enabling technologies are advancing at unprecedented levels. Precision manufacturing techniques, advanced modeling, artificial intelligence, and others are all culminating to accelerate the design maturity of EV at an unprecedented rate. This is helping improve things like battery manufacturability, whether it's through 3D printing or other manufacturing techniques, size and weight reduction of the battery, or enhanced power density, and of course, performance, charging and discharging. So the advancement of these other electronics computational efficiencies are what are enabling us to meet this demand. And finally, disruption of the traditional OEM model is helping to drive technology faster. Several of the top EV manufacturers in the world have never produced an internal combustion engine, nor even existed 20 years ago. One of those, Tesla, has even taken steps to offer all of their IP openly to the industry. Can you imagine if GM or another major manufacturer OEM took this approach 20 or 30 years ago, or even today? Hundreds of startups now exist to invent and develop advances in EV design, from batteries to automated driving to charge control electronics and algorithms. This disruption can be seen as a chaos to the established industry. However, it is also opening up doors to new lines of thinking, fleshing out the best solutions, and moving the whole industry forward faster. On the other side are market restraints. The growth will be constrained to the early adopters as it is today, until the cost of the EV makes financial sense for the general population. This includes things like range, the estimated miles per gallon that it receives, initial costs, and maintenance costs. The general public also isn't willing to accept a zero emissions car with a dirty manufacturing process or a fuel supply chain process. The entire supply chain has to be as green as possible. Adhesives research offers many products that are well suited to support advancements in EV battery design. For the last 50 plus years, we have continued to invest in expanding our capabilities to be able to quickly respond to new and challenging demands. While not everything is possible today, we pride ourselves on working with industry leaders like yourselves to set the direction of the market. When you choose Adhesives Research as your partner, you will not only receive the performance adhesives that you need to meet your technical requirements, but you also have access to our decades of experience. From this experience, it puts us in an ideal position to help navigate your company through the complex process of designing specific performance adhesives to meet your needs, customizing and supplying them in the format that makes sense and enables your processing and manufacturing, and perfecting the application techniques needed to use those in a more efficient and effective manner. Adhesives Research has a wide range of web-based, pressure-sensitive, and/or curable adhesives that can serve in a variety of battery applications. These range from precision dielectric, chemically stable barrier adhesives, to conductive films that reduce vibration, such as foam tapes, EMI shielding products, current carrying products, and general bonding and sealing of different components. At the end of the day, we want you to achieve extraordinary outcomes: faster speed to market, throughput improvements with your manufacturing process, and an overall cost of goods sold reduction. I will now turn the presentation over to Matt Hunley. Matt will be presenting specifically on some of our conductive technologies. If you have any questions regarding conductive or other adhesives that could be used in your application, we would be happy to respond after his portion of the webinar.
Good afternoon. My name is Matt Hunley. I'm the group leader for the Engineered Solutions Research and Development team here at Adhesives Research. And I'm excited today to talk to you guys about our conductive pressure-sensitive adhesives that can enable smart and economical battery design for EVs and more. As we all know, right now, there's a relatively small number of electrical vehicles on the road, less than 10 million or less than about 1% of all the vehicles. But by 2040, there's supposed to be dramatic growth. Expected 900 million electric vehicles to be sold by the year 2040. So improvements in the battery design and the battery efficiency are critical to drive this expected demand. The manufacturability, the weight, the packaging, and performance are all critical factors for energy storage. Our thin film adhesive layers can help advance the battery designs by providing electronic, ionic, and thermal conductivity or insulation, while also bonding and creating adhesive joints. They can withstand very harsh environments and applications that are critical for these electric vehicle batteries. They enable high-speed roll-to-roll production. So dealing with an adhesive tape, you're dealing with a roll instead of a liquid adhesive. And they reduce the overall size and weight through ultra-thin laminations. Adhesives research conductive PSAs provide several specific performance benefits as well. They provide precise, directed electrical conductivity. We can tailor exactly where the conductivity is, whether it's isotropic in the X, Y, Z planes, or anisotropic, where we have Z-axis only conductivity. We tailor this design through the selection of specific fillers, including carbon black and other metal particles. And by designing these high performance adhesives, we can get very fine pitch connections. So down to 300 microns by 300 microns to make a conductive adhesive bond. We're able to withstand demanding environmental conditions with our PSAs. They can withstand temperature extremes from negative 30 degrees Celsius all the way up to 120 Celsius, and even damp heat with high humidities up to 95% RH. They're natively UV and chemical resistant to provide long service lives. And they can be designed with silicone, acrylic, or rubber adhesives to match the conditions and the performance requirements for each application. These adhesive PSA tapes also enhance manufacturing efficiency. They're easy to handle and clean. There's no liquid chemicals to deal with, no hazardous chemicals or mess to clean up after applying the tapes. The PSAs take a very limited heat and pressure lamination, so it's very simple and straightforward to apply them to any substrate. And they can be tailored for wide-ranging substrates, from metal to films to very low surface energy substrates. So our conductive PSAs provide a very attractive alternative to costly silver-filled electrically conductive adhesives and other liquid options. Our portfolio includes pressure-sensitive adhesives as well as heat seal adhesives and even insulating barrier adhesives. The conductive PSAs enable very high-speed roll-to-roll production, easy-to-handle films. We manufacture products with resistances from a few milliohms all the way up to several ohms. Our electrically conductive heat seal adhesives give us stable performance under even more demanding environmental conditions. However, these, unlike a PSA, are non-tacky films, so they require a heat tack step and a cure processing step. And although not conductive, many applications such as batteries require sealing or barrier adhesives as well. So we offer several non-conductive films with excellent water, moisture, and oxygen barrier properties. To talk about our product portfolio, I'll have to talk about the different constructions. So transfer tapes are a single adhesive layer separated or covered on each side with a release liner. Transfer tapes are used to bond two conductive substrates and conduct electricity between those substrates in the Z direction. We have several products that have strong Z conductivity, but also tailorable isotropic or anisotropic conductivity. With a percolated filler network, such as a carbon black filled system, we can get very isotropic conductivity, so we conduct in all the directions, X, Y, and Z. If we switch to a more specialized carbon black and metal filled system, we can control that conductivity in only one direction, the Z-axis, to conduct electricity only between the two conductive substrates that are being bonded. Single-coated tapes, however, are adhesive coated onto a conductive backing. And this conductive backing is typically a tin-coated copper foil or a copper mesh that conducts very well in the X and Y directions along the length of the tape. These materials are typically used for solar panel busbar applications where you have to collect current and deliver, as well as when there are profile and height mismatches in the application. They're flexible and conformable and can easily overcome the height mismatch. Our double-coated tapes have a conductive carrier between two layers of adhesive. The conductive carrier is normally a nickel or copper coated non-woven, so they are quite conformable and bendable. So they're used in flexible applications where we need to conform to the texture of the substrate. The adhesives are also tailorable on each side and typically provide very good conductivity in the X, Y, and Z direction. Copper-coated foil and copper-coated non-wovens are very common conductive carriers, but tin-coated copper is also available to reduce oxidation of the copper in the most corrosive environments. Most of our PSAs are very well performing over a wide range of environmental conditions. However, some applications have very demanding temperature cycles and humidity cycles. In these applications, we recommend a heat seal adhesive, so specifically EL93853. This heat seal is non-tacky, needs to be cured after it is applied and laminated, but under temperature cycles provides much more stable contact resistance relative to the PSAs. You can see in the plot here on the slide that under thermal cycling from -45 to +85°C over 16 days, the heat seal adhesive has much more stable contact resistance than the pressure sensitive adhesive. Here at Adhesives Research, we believe we are the global leader in custom adhesive development. We're an expert developer and manufacturer with experience in a wide range of products, from adhesives, tapes, specialty films, coatings, release liners, and even transdermal drug delivery technologies. Our portfolio is generally split up into two different industries, the healthcare industry and the electronics industry. But in both, we specialize in the formulation and manufacturing of tailored technologies, where we work with the customer to understand their needs and design a product that enhances their performance. We bring design flexibility, development capabilities, and extraordinary outcomes to all of our design partners. We have extensive polymer science expertise, including we have 2 R&D facilities at Glen Rock, Pennsylvania, our corporate headquarters, as well as in Limerick, Ireland. We have extensive development capabilities, production around the globe, as well as state-of-the-art converting equipment here in Glen Rock, Pennsylvania. And we're able to offer faster speed to market, improved throughput and COGS reduction in order to maximize your revenue outcomes. So just within the electronics and industrial portfolio, we talked today a lot about the electrically conductive adhesives and films, but we also have a very broad portfolio with many different offerings. We offer optically clear adhesives. So these are for flexible to flexible or flexible to rigid optical components, such as flat panel displays, flat screen TVs, and touch screens. We have several dual stage adhesives. So these are pressure sensitive adhesives that are relatively straightforward to apply, but can be cured after application to create a structural bond and very high performance. I mentioned earlier, we have moisture barrier adhesives that form strong flexible bonds while providing excellent moisture and oxygen barrier properties. We also offer splicing tapes for paper and flexible packaging processing industries. And our ultra-low extractables release liners are leading the industry in providing low silicone liners for the hard drive, electrical components, and advanced medical products industries. So thank you for listening to our talk today. I hope you enjoyed our technical discussion, and we would love to hear from you. The contact information is on this slide, so please reach out.
Again, thank you for watching the presentation today. Thank you for your attention. At this point, we do have at least 15 minutes for Q&A. So at the bottom of your screen, there should be an option for Q&A to submit questions to us. Please feel free to submit the questions and we'll go through as they come in. All right, the first question we have here are, which of your adhesives can be used to replace silver paste? This is a good question because the answer is it depends. And it truly depends on what your application is and where you're using the tape or adhesive in your system. I talked a little bit about transfer tapes. If you need the conductive paste to bond between two different substrates, holding the substrates together and conducting between them, then we would suggest a transfer tape or a double coated tape for that application. If you're using silver paste as more of a bus bar or a path to conduct electricity from one component to another, a single component tape would most likely be most appropriate replacement there. All right, the next question I see here is, what applications require conductive non-woven materials? So the non-woven materials that we use in our double-coated tapes are really to add flexibility to the tape as well as provide conductivity in the X and Y direction. So it's not necessarily that the application requires a non-woven, it just provides a lower density, more flexible carrier than a metal film for the application.
Yeah, just to add to that, that's a fairly open-ended question. If there's a specific application that you have questions, if that would fit in yours, please, we can reach out afterwards or send us a note. But it is very dependent on essentially the flexibility and the conductivity requirements that you're looking for, whether transfer film, conductive non-woven, or a solid foil may work best in your application.
Great. Yeah, one point to elaborate on what Andrew said, typically for very high amperage applications, a solid conductive film as a carrier is more preferred. But if we're talking about lower currents for conductivity, the non-woven can be preferable due to its lower density and higher flexibility. The next question that came through was about thermal cycling. Can the conductive adhesives withstand thermal cycling, and what is the expected lifespan? So I did describe this a little bit, talking about the heat seal adhesive earlier. Most of our PSA adhesives can withstand thermal cycling and have been used by current customers in the field for many years. In laboratory cyclic testing, they generally survive a few thousand cycles, going from -45 to +85. There is a little bit of creep in the resistivity over time during that cycling, maybe by about 2x. Our heat seal adhesive, however, EL93853, over greater than 4,000 thermal cycles, shows very little creep in resistivity over time. The resistivity on the final cycle is very close to what we see on the initial cycle. And in the laboratory cyclic testing, we have tested that well over 4,000 cycles with no loss in performance and no loss in adhesion. All right. Moving on to the next question. Could these adhesives be used to eliminate soldering? And yes, in many applications, our PSAs can be used to eliminate soldering. So the PSAs by themselves will create an adhesive bond either to a surface or between two surfaces. So if soldering is used to connect two individual substrates, a PSA could be a very good choice to eliminate the soldering step and improve efficiency in manufacturing.
Yeah, and this is one application that PSAs can excel depending on the rest of your component makeup. As you know, soldering requires generally fairly high heat, and a lot of flexible or new materials that are being used today cannot withstand that. There is some development in that field, but still a ways off from really having solderable plastic substrates. So a PSA that has near solder resistivity and capacity is a great substitute. It also doesn't require any sort of dwell on the line if you're doing a roll-to-roll manufacturing. So there's a lot of application where a PSA or heat seal can be a wonderful alternative to soldering.
All right, next question that come through is, do you have products with thermal insulating properties? And this is a good question. It's a little bit opposite of a lot of what we've talked about today. The presentation really covered most of our electrically conductive materials, which at the same time have some thermal conductivity properties. But we do have insulating pressure sensitive adhesives or pressure sensitive adhesives that do not have electrical conductivity and would act as insulating layers. Those would be our first bet for trying to prevent thermal conductivity as well. I don't believe at the moment that we've studied the thermal insulation properties too well, but this is a good case of an area where our company specializes in partnering with customers. So if you have a specific need and are really interested in a tape that meets certain requirements, we are very willing to investigate and possibly even develop a new product for your needs.
Yeah, correct. And most of the adhesives that we work with may differ from some of your other use expectations of adhesives in battery applications. Ours are generally a thinner film ranging from a few microns up to 200 or 300. And the intention is more to bond the materials in your stack up or need versus be the insulative material such as a foam or other thermally insulating material. So we do work with a lot of vendors. If there's a material that you're looking to hold in place or bond between two cells or other components within a battery, that's where we would excel, is to find the right adhesive to bond those together and hold them in place versus perform the insulation that you're looking for.
Thanks, Andrew. I've got two questions here that are actually pretty similar. The first is there any shrinkage associated with the curable adhesives? And for this heat seal that we talked about today, there is very little shrinkage on cure. So there is not a large buildup of stress, if that's the worry. Most of our products, our PSAs, are 100% solids. We're not selling liquid adhesives generally. So during cure and during application, there is no solvent vapor or water vapor that needs to be evaporated off. And during cure, there's generally very limited shrinkage and no volatiles being generated. A related question is about coefficient of thermal expansions. Can you match the CTEs for any substrate material? And that's a good question. For the transfer tapes that we sell, which are unsupported adhesive films, the coefficient of thermal expansion is actually relatively complex. So there are multiple components in the mixture. The filler particles, the binder resins, and actually in many products, we see certain temperature ranges where there's a positive coefficient of thermal expansion and certain temperature ranges where there might be a negative portion of the CTE. So in these cases, we like to recommend that we really discuss and understand the application and the needs and the conditions that the product will be seeing to help select the right adhesive for that application. For our supported carrier products, our single coated and double coated tapes, generally the carrier material, the metal mesh or the metal film, is dominating the CTE of the full construction. Just simply because of the mechanics, that's the much more rigid layer, so it's going to dominate in any expansion or contraction. So in those cases, it's more straightforward to try and match up the carrier material CTE with any substrate that you're interested in.
And I think Mike or Matt talked about this a little bit, but one of the other key benefits of a polymer such as what we offer is the ability to bond together materials with dissimilar thermal expansion coefficients. In the event where you don't have any other option except to bond two things together, and you need something to be able to absorb some stress while they're expanding or shrinking, polymers are great use for that and can be used as kind of an intermediate field.
All right. What benefits can your products offer in terms of battery manufacturing, scale up, and cost? So some of the benefits that a roll-to-roll tape product can offer in manufacturing are elimination of liquid adhesives, the need to apply liquids and cure the liquids, as well as a more efficient and faster throughput to affect the cost and efficiency of battery scale up. All right. On the next question, can the barrier adhesives withstand thermal cycling and environmental exposure? Yes, it's very similar to what we talked about earlier for the heat seal versus PSA conductive adhesives. So we have barrier adhesives with different chemistries. Some chemistries are much better at higher temperatures than others. So we have some that are better at lower temperatures where we don't have a problem with flow under temperature or under heat. And we have some other barrier adhesives that can withstand higher temperatures, closer to 85 degrees Celsius. Most of our barrier adhesives are good for environmental exposure in terms of sunlight, UV exposure, and can withstand degradation, withstand degradation under the environmental conditions. So again, for these applications, it's important to understand what the actual and realistic thermal cycles that would be seen in the field are to select the right resin and binder material for the adhesive for these barrier applications. The next question, do you have any conductive PSA tapes that are chemically resistant to propylene carbonate solvents? Yes, we do. We have some. We have one specific transfer tape option that has very high chemical resistance. So it's resistant to most solvents as well as corrosive and basic conditions. That product is EL93802. We'd be happy to talk about that a little bit more and discuss a little bit more the various solvents and conditions that would be exposed to. The next question is more about process for custom development. What are the general timelines and procedures to start a custom product development project? And the timelines will vary depending on the needs of the specific project. But to go through the procedures first, generally we'll meet and discuss the needs of a project. So what the critical to quality attributes are, the specific performance metrics, and we'll generally determine if we have anything off the shelf that meets those needs or even gets us close to those needs, and that can give us a head start towards custom product development. So based on some of that initial testing, we will identify and discuss, and these are always through back and forth conversations, we discuss what the technical path forward would be to develop a project to meet the specific requirements. And generally those timelines range from 3 months for relatively simple developments, and it can go up to a year if it's very complicated and requires in-depth chemistry development. So the next question, can I get free samples to start testing? And yes, we do. We'll have initial conversations about your application, figure out what your needs are. So we look at our catalog of standard products to see what might get us close to those needs, what might be the most appropriate samples to test initially, and then we'll discuss. Depending on which products are required, sometimes we do sampling at the beginning. Yeah. All right, that's a lot of good questions, everybody. Are there any more questions to come through? So after this session ends, we will post the link. The live session was recorded, so we will send out the link to everybody to rewatch for reference. If there are no other questions, thank you everybody for participation today. Thank you for your interest and all the good questions. We look forward to hearing from you soon.